Okay, so we're looking at the second year Stats and Mechanics textbook. We're on chapter 6, which is projectiles, and we're looking at exercise 6b, which is finding vertical and horizontal components of the velocity. Okay, so we have got a particle on level ground that's being projected. And this differs from question 1 in that it doesn't actually give us the value of the angle. So the angle is alpha, and they give us tan alpha. So we'll come back to that. And it's being projected with a velocity of 35 meters per second in that direction. Okay, right, so let's have a think about what to do when they give you tan alpha. Now, one option is, that for this question, which would work absolutely fine, is to do inverse tan of 5/12, because basically I need sine alpha and cosine alpha to find the horizontal and vertical component. So you could do inverse tan of 5/12, and then as long as you don't clear your calculator, if you then do sine of that answer, you will get the exact value for sine alpha. Okay, so it might seem like the way I'm going to do it is overcomplicating it, but this is how you should be tackling it, and this will help you when you get onto some harder questions, whether it's in mechanics, whether it's in core maths for your trig. Right, so because really, if I just change colour, okay, so if I've got a right angle triangle, and I know that tan, which we can actually see it, okay, and I know that, so I'm no longer drawing out the velocity they gave me in the question, but if I just draw a right angle triangle, and I know that tan alpha is 5/12, and obviously I know from trig, from SOHCAHTOA, that tan is opposite over adjacent. If I label those on my triangle, so compared to where alpha is, that's the opposite side and that's the adjacent side. If I then do Pythagoras, so 5 squared plus 12 squared, and then square root that answer, I get a hypotenuse of 13. So then I can say, well, sine alpha is opposite over hypotenuse, so 5/13, and cos alpha is adjacent over hypotenuse, so 12/13. Now, as I said, I think with your current calculators, if you just did inverse tan of 5/12, and then as long as you don't clear the answer, if you then do sine of that answer, you will get 5/13. And then if you do it again and do cos of that answer, you will get 12/13. So for this question, that would work, but this is sort of the proper way to do it. Okay, but either way, we've got values of sine alpha and cos alpha. Okay, so I'm after the horizontal and vertical components. So again, I'm just basically making a right angle triangle. So the horizontal velocity is going to be 35, and then that's adjacent to alpha. So 35 cos alpha. And I worked out here that, so you can't see that, I worked out there that cos alpha was 12/13. So that's 35 times 12/13. Sorry, I typed that in wrong. 12/13. So let's round that. So I'm getting that's 32.3 meters per second. And then let's change colour just because we can. The vertical velocity, so this is opposite the angle alpha. So that's going to be 35 sine alpha. And again, over here, I've worked out that sine alpha is 5/13. So that's going to be 35 times 5/13. So that I get as 13.5 meters per second. Okay, so there's my vertical velocity and there's my horizontal velocity. So going on to answer part B, I'm writing that as an I and j vector. The initial velocity, so the horizontal is going to be my I component, so that's, sorry, you can't see, so the horizontal is my I component, so that's there, it's going to be 32.3 I, and that's moving to the right, so it is positive. and the 13.5 is my vertical velocity, so that's my J component, and that's up. So again, that's positive. And let's put the units in as well. Okay, so let's just double check that. So 32.3 and 13.5. Yeah, we're good.